Okay, we're getting into the last half of Chapter 7 here. We're going to be doing a lot of what's called factoring. Before we get into factoring, we got to learn how to solve polynomial equations in factored form. Can anyone tell me what a factor is? Like, what would a factor of 16 be? 4. Right? 4 times 4 gives me 16. It's another factor of 16. Besides 4. In other words, what else is 16 divisible by? What? 8. What else? 2. What else? 1 and itself. Right? 1, 2, 4, 8, 16 are all factors of 16. Does that make sense? So it's things that can go into that number. That's what a factor is. So, a polynomial is in factored form when it is written as a product of factors. Just like if we had 16 and I wrote it as 2 times 8, we can do the same thing with a polynomial and have two things being multiplied together to give me that polynomial. So here's a few examples here. Our first polynomial in standard form is x squared plus 2x. Factored form of x squared plus 2x would be x times x plus 2. If I were to multiply this out, I should get back to my standard form over here. So if I distribute my x here, what's x times x? X squared. X times 2 gives me 2x. So this is factored form. X is a factor of x squared plus 2x. X plus 2 is also a factor of x squared plus 2x. Just like if I had 8 times 2 being multiplied to give me 16. Does that make sense? And like I said, we'll get into the actual factoring part within a few days, a couple of weeks. Okay? The next one here, x squared plus 5x minus 24. Factored form of this is x minus 3 times x plus 8. If I were to FOIL this out, I would get back to my original standard form. But this is what factored form will look like of polynomials. Any questions on what factored form is going to look like? Two other polynomials being multiplied together. When I multiply them together, I get to my original polynomial. This last paragraph at the bottom, when one side of an equation is a polynomial in factored form, so one of these two things, when one side is in factored form and the other side is 0, meaning it equals 0, we use what we call the zero product property to solve the polynomial equation. We'll talk about the zero product property on the next slide. The solutions of a polynomial equation are also called roots. So you can call them solutions or you could call them roots. We're going to use this property called the zero product property to solve these equations. And I can only do it when one side of the equation is a polynomial in factored form and the other side is 0. If this side is like a 5, I can't use the zero product property. If it's any number other than 0, I can't use it. Any questions before I talk about the zero product property? Am I good to move on or are we still writing? Okay, I'll give you a few more seconds. Okay, moving on. The zero product property. It sounds really complicating, but if you really just think about it, it's honestly pretty easy. If the product of two numbers equals 0, then at least one of the numbers is 0. Okay? So if you want to look at it down here, If I have two numbers A and B equaling 0, then I know that at least one of these must be 0, right? Because I need a 0 in one of these spots for it to equal 0. Does that make sense? If these two numbers are anything other than 0, will this equal 0? No, I know at least one of them has to be 0. Does that make sense? This is the property we're going to apply to our polynomials in factored form when we're solving these equations. Is there any confusion on this property? Does it make sense to us? If I've got two numbers being multiplied together and they equal 0, I know that one of those numbers must be 0. Does that make sense? I'm not getting any feedback from you guys. This means yes, this means no. It's making sense to us. Okay. Do we have this property written down? 1 second, okay. Okay, let's look at some examples here. Solve each equation. Going back to solving equations here. I have 2x times x minus 4 equals 0. The left side of my equation is a polynomial in factored form. It's two factors being multiplied together. 2x is one factor, x minus 4 is the other factor. The polynomial in factored form is set equal to 0, so I can use my 0 product property here. If I've got two things being multiplied together, a times b, in this case a is 2x, b is x minus 4, then I know that one of those two things must equal 0, right? So how I'm going to do this is I'm going to take each factor, 2x, x minus 4, and set them equal to 0. Okay? I'm going to do 2x equals 0, x minus 4 equals 0. Because I know one of these two polynomials must be 0. So I'm going to find all values of x that make this equation equal 0. So for 2x equals 0, how would I get x by itself? Uh-oh. Chapter 1 stuff coming back into play. Yeah. And back to our inverse operations, right? X is being multiplied by 2. What's the inverse of multiplication? Division. So I'm going to divide by 2. Whatever I do to one side, got to do to the other. 0 divided by 2 gives me 0. There's one of my solutions, one of my roots. Now I've got to solve x minus 4 equals 0. X minus 4 equals 0. How would I get x by itself? Add 4 to both sides. 0 plus 4? 4. There's my other solution, my other root. And I'm done with the problem. How do you feel about that? Good? If I'm ever unsure about my answer or answers, what do you guys think I could do? Plug them in, check to see if it gives me a true statement. If I plug 0 in for my x's here, what's 2 times 0? 0. What's 0 minus 4? Negative 4. What's 0 times negative 4? 0. Does 0 equal 0? Yes, it does. 0 checks out. If I plug 4 in for x, what's 2 times 4? 8. What's 4 minus 4? 0. What's 8 times 0? 0. Does 0 equal 0? Yep, they both check out. Are we okay with that? How are we feeling about understanding the 0 product property? If two things are being multiplied to equal 0, I know one of those things must equal 0, so I set them equal to 0. Okay? And then solve for your variable. Can I erase and move to letter B? x minus 3 times x minus 9 equals 0. Is one side of my equation a polynomial in factored form? I got two factors being multiplied together. Yes or no? Do I have two factors being multiplied together? Yes, I do. Is the other side of my equation 0? Yeah. So can I use the zero product property? Yes, I can. So someone help me set this up real quick. There we go. Two things being multiplied together to equal 0. So I know one of these two things must be 0. So I take each factor, set it equal to 0. Now I'm just solving each of these equations for x. X minus 3 equals 0. How would I get x by itself? Add 3 to both sides. X equals 3. X minus 9 equals 0. How would I get x by itself? Add 9 to both sides. X equals 9. Once again, if you're always unsure about your answer or answers, you can plug it back in, see if you get a true statement or not. Plug 3 in. What's 3 minus 3? 0. 3 minus 9? Negative 6. What's 0 times negative 6? 0 to 0 equals 0? Yes, it does. Plug 9 in. 9 minus 3? 6. 9 minus 9? 0. 6 times 0? 0. 0 equals 0. They both check out. We okay with example 1A and B? How are we feeling after two examples? Good. Sometimes we can have repeated roots. When two or more roots of an equation are the same number, the equation has what we call repeated roots. So if that's the case, we would just say, hey, we have repeated roots of negative 2 or whatever number it is. I'll show you some examples of what that's going to look like. Okay, let's look at some examples that have repeated roots, or that might have repeated roots. Solve each equation. This is my last slide of examples, by the way, then we're done. Letter A, 2x plus 7 times 2x minus 7 equals 0. Is one side of the equation a polynomial in factored form? Yes. Is the other side of the equation 0? Yep, so can I use the zero product property? Yep. So what are my two factors? And what else? 2x plus 7, 2x minus 7. Those are my two factors. What am I going to do with those? Since they're being multiplied and they equal 0. What am I going to do? Set them equal to 0. 2x plus 7 equals 0. 2x minus 7 equals 0. So the first one, 2x plus 7 equals 0. What would be my first step to get x by itself? Subtract 7 from both sides. Zero minus 7 gives me negative 7. Last step to get x by itself. Divide by 2. Do I get a whole number when I do negative 7 divided by 2? Nope. Can that fraction be reduced at all? Nope. I'm going to leave it as negative 7 halves. Be okay with my first solution, my first root. Okay, next one. What would be my first step to get x by itself? Add 7 to both sides. 2x equals 7. How do I get x by itself? Divide both sides by 2. X equals 7 halves. You okay with my answer here? Do I have a repeated root here? Are these the same number? No. One's a positive, one's a negative, right? Two different numbers. So I do not have any repeated roots here. I only have a repeated root if it's the same exact number for both equations. Okay? Questions on A? B. X minus 1 squared equals 0. What's another way to write x minus 1 squared? X minus 1 times x minus 1. Can I use the zero product property here? Yeah, I've got two factors being multiplied. They're set equal to 0. So what do I need to do? Set them both equal to 0. Take each factor, set them equal to 0. It's the same equation, right? So what do I do for both of them? Add 1 to both sides. What do I get for both of them? 1. So what do I have here? A repeated root. So I'd say repeated root. Can't write. Of x equals 1. That's what I'd put. We're okay with that. So I only have one solution here. Just x equals 1. 1's the only number that's going to make this equation true. We okay with letter B? Last example here. X plus 1 times x minus 3 times x minus 2 equals 0. Can I use the zero product property here? Why? I've got 3 things being multiplied together now. Same concept's still going to apply, right? Even if I have 3 things being multiplied together and they're set equal to 0, I know that still at least one of those things must be 0, right? So I'm going to take all 3 of my factors, x plus 1, x minus 3, x minus 2, set each of those equal to 0, and I have a chance of possibly getting 3 solutions here, unless I've got a repeated root. So x plus 1 equals 0, x minus 3 equals 0, x minus 2 equals 0. First one, how do I get x by itself? Subtract 1. X equals what? Negative 1. Next one, x minus 3 equals 0. How do I get x by itself? Add 3. X equals 3. And the last one, add 2. X equals 2. Do I have any repeated roots? Nope. So I've got 3 solutions here. X equals negative 1, 3, and 2. If I plug each of these in, I will get 0. Okay? How do we feel about the zero product property? If I've got 2, 3, 4 things, 5 things being multiplied together, and they equal 0, I'm going to take all of my factors, set them equal to 0, solve all my little equations. Okay? Does that make sense? Here's your assignment. Page 365, numbers 3 through 24, all. You should do all of them, not just the evens, not just the odds. Page 365, numbers 3 through 24, all. Make sure you get the correct heading on your paper. Name, date, period, assignment, upper right-hand corner. This will be 7.4, homework number 1, whenever you're looking for it on Canvas. So you may want to write that at the top of your paper as well. This will be due Wednesday, the 10th on Canvas. Okay? Are there any questions for me before I end the recording about the notes?